Welcome to this course on Models, Views, and Delegates. In the Intro to QML, Intro to Qt Quick Controls and Positioners and Layouts courses, you learned how to use various items and controls, make property bindings between them, and arrange them within your application's window. This course focuses on what to do when you need to go beyond simple property bindings and work with more complex structured data. The Qt framework provides a pattern called Models, Views, and Delegates for working with such data, and we're going to introduce each of these concepts to help you understand what they are and how to use them. When we talk about models, we are referring to any structured data, which, for the purposes of this course, will be defined within the QML language. Views create visual items that represent the data in the model. These items are known as delegates. Views manage how these delegates are laid out, how they interact with the data, and how they visually represent it. Delegates themselves are visual components that define how to render and interact with a single data item from the model. We define one delegate in QML, and the view creates as many instances as needed to display the data. Starting with an initially prepared project, this course will guide you through several sections that you can follow along with. At the end of each section, you'll be encouraged to experiment with what you've learned and try out your own ideas. By the end of the course, you'll be able to build a live weather application. The Git repository for this course contains folders for each section with a completed main.qml file for reference, not the entire project. If you're ever unsure of what you've done, need to reset, or want to review a section, you can copy any of the reference main.qml files into your project at any time. To begin the course, locate and download the project named 00, Initial Project, from the Git repository. Once you have a copy on your computer, open Qt Creator and use the File, Open File, or Project option. Open the cmakelists.txt file in that folder. When asked to choose a configuration, any version of Qt above 6.5 should work fine. Once the project opens in the project tree, you can open main.qml to see the imports and an application window with some other elements already set up. Give it a quick build. The project should run right out of the box. This is where we'll begin our journey, learning about models, views, and delegates in practice. There are many types of models that we'll encounter and use in QML. The simplest example could be a single integer, where the model represents the full range of integers from 0 up to, but not including that number. We can also work with a list-like structure, which has one dimension, we'll call rows, such as an array of strings or a contact list, where each item has multiple fields, we'll call these roles, like name, email, phone number, and so on. A more complex example would be a table-like structure, which has both rows and columns. Even more complex models may have a tree-like structure, with nested rows and columns forming a parent-child relationship. Before we discuss those models, we need to discuss the model index. What is it? We read and write data in a model through its index. An index comprises a row, a column, and a parent index. In most simple cases where the model has only rows, the column and parent index default to 0 and null pointer, respectively, so we don't usually need to worry about them. Each index in a data model may also have several roles. A role represents a single piece of data accessible at a given index. For example, in a model containing a list of images, roles could include URL, file size, width, height, and format at each index. Similarly, in the contact list example, roles might be name, email, and phone number. While QML hides much of the C++ details behind these indices, it's helpful to understand that they exist and how they work. In the following sections, we'll start by exploring simple models and work our way up to more complex examples. Along the way, we'll introduce different view types and see how delegates are used within those views to display items from the various models. We'll start with the most basic type of model, which you might have seen before, an integer model. For simple integer models, the index has rows going from 0 to a number -1, one column, which defaults to 0, and no parent index, which defaults to null pointer. However, since there are no roles and no specific properties to access the data, we use the specially provided context properties, modelData, and index, which are made available to the delegate. In this case, modelData will give us the value of each integer, and index is simply the row number. Let's see how that works. First, we'll create a repeater inside the column layout. Set the repeaters model to the number 10. It will create 10 instances of whatever delegate we choose. This is equivalent to a JSON array or a property list of integers. For the delegate, we'll use a label. Repeater is the first time we explicitly encounter a delegate, that is, a component we declare with the intention of creating multiple instances, one for each index in the model. The column layout will manage the delegate instances that the repeater creates, since the repeater reparents the created items to its own parent, which in this case is the column layout. We'll use the fill width layout attached property to ensure that all the labels are the same width, matching the largest label, since the column layout sizes around them. So let's set the text property to modelData and index. Now let's run it. But check out the errors. ModelData is not defined. The warning occurs because the compiler and QML lint doesn't know where modelData and index come from at compile time. The pragma component behavior bound at the top of the file enforces this error. These are called unqualified properties, and without the pragma, they may happen to work at runtime when the just-in-time compiler matches the properties with the model roles. So how do we fix it? We need to declare modelData and index as required properties. Required properties are an important concept. If a delegate has required properties, the QML engine will check if the name of a required property matches one of the model's roles. If it does, the property will automatically bind to the corresponding role value from the model and update whenever it changes. While you could choose not to use required properties, which is not recommended, it's always a good idea to use them to pass modelData into your delegates whenever possible. If no required properties are present in the delegate, the model's named roles are injected into the delegate's context for unqualified runtime access. However, this approach prevents the compiler from optimizing your code, and any injected context properties will be invisible to the compiler or QML lint. On the other hand, the presence of even one required property will prevent any context properties from being injected into the delegate's context, including modelData and index. Using required properties has several advantages. First, it lets you programmatically define which properties your delegate requires. Second, the compiler knows ahead of time what your intentions are, so there's no guesswork at runtime. Finally, if your model's roles or required properties ever change, you will at least get a runtime error. Let's add the required properties to the label delegate. Run the application again, and now you'll see the 10 labels displaying the modelData and index values without any warnings or errors. So far, we've covered a lot. We now understand components and elements, and how delegates are components that can be created multiple times according to a model. We've also learned about model index, which includes rows, columns, roles, and potentially a parent model index. We explored the special roles modelData and index used to access raw data and the row number in models without roles. By creating a simple number model using a repeater, we've seen how to declare a delegate with required properties, and we've explained what they are, how they work, and why they're a good idea. Let's do some more coding and add some color to our example. Let's use this next example to explain the difference between modelData and index by looking at the next type of model, a simple JSON array of strings. First, change the repeater's model to the following set of strings. Since the model now contains strings, we'll change the type of the required modelData property to string to match the data we're working with. Next, let's add a custom background to the label by setting the background to a rectangle. Now let's give the rectangle a color. Set the color property to the modelData. But there's a new problem. The modelData property is defined on the label, not on the rectangle. To fix this, we need to qualify the property. First, assign an ID to the label, for example, label delegate, and then update the rectangle's color property to label delegate.modelData. Now you should see we have labels nicely colored according to the array of strings. We can see that the label's text color doesn't look good against some of the colored backgrounds. To fix this, we need to supply a background color and a text foreground color. We can do this by upgrading our JSON array to include objects instead of only strings. Our first task is to modify the model to be an array of JSON objects, each with two keys, background color and color. The background color will be used for the background as we were doing before, and the color key will be used to set the text color, which we'll initially set to white. There's a sneaky reason I'm calling this color rather than foreground color. You'll see why shortly. When you're done, the model should look like an array of objects. Next, change the modelData required string property to background color and add a new required color property for the text color. When you add a property and make it required, you first declare the property and then make it required. If the property already exists, you can upgrade it to being required without declaring it again. In this case, we'll upgrade the label's existing color property to a required property, and the color role in the JSON objects will map perfectly. Now, modify the text binding to reference the background color and color properties, as well as the index. Next, change the background rectangle's color binding to use the background color required property. You might have noticed that the label's color property is of type color, but we're mapping it to a string role in the model. This works because it's possible to assign a string to a color property. QColor has a string constructor. We can see this in the label's text, which shows the color's internal hexadecimal color value rather than the string name we constructed it from. Finally, let's change the text color for the background colors. Run the application, and you'll see that the appropriate text, colors white and black, are applied to the different label delegates. Now that we understand basic models and delegates, let's explore Qt's powerful built-in models that offer more advanced functionality.